Okay, today we're going to go over finding the trig functions with a given point. So let's look at this example. The point given below is on the terminal side of an angle theta. Find the exact value of each of the 6 trig functions of theta. All right, so basically we're given an x value and a y value. If we look at we just look at, let's see how that looks per se. Negative 5, 12. That's over here, negative 5. And I'll say this is 12. So negative 5, 12 is right here. And if we draw a line, what we're basically doing is just forming a right triangle. Okay. So now we have the distance here. And we have this distance. This is 5, and this is 12. And this is the hypotenuse, or when we're dealing with a unit circle, we deal with the radius. So we call that r. That's why you see the r in the formulas here. Okay. So now we can find out what r is, because we have to find all 6 trig values. So we can use the Pythagorean theorem. Okay, which is r squared is equal to x squared plus y squared. Okay, well, they would say c squared is equal to a squared plus b squared. Okay, but in this case, we're dealing with x, y, and r. And so r squared is equal to, we have 5 squared plus 12 squared. And so we have 25 plus 144. And that gives us 169. That's r squared. So to find out what r is, you take the square root of 169. And I do believe that that's 13. So now we have r. So we have x. We have r, and we have y. So now you're able to find the trig functions of theta by the following functions. Okay. And so x is equal to negative 5, y is equal to 12, and r is equal to 13. So you just substitute. So sine of theta is y over r. Okay, y, and this is the all right, the theta. All right, and so we have y the opposite over hypotenuse. Again, we're still dealing with the SOHCAHTOA, okay, phrase. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. And then on the right side, you have the inverses of the 3 main ones. Okay, so now I think you're able to find out what sine of theta is. All right, so sine of theta, y over r, so that's 12 over 13. Cosine of theta is x over r, so that's a negative 5 over 13, and then tangent theta is y over x, so that's a negative 12 over 5. And then you do the same cosecant theta. That would be the inverse of sine, so that would be 13 over 12. And then secant. Let me erase that. Let's see. Got that. All right. So we found cosecant. Now the inverse of cosine is secant. Just remember they don't start with the same letter. And those are the sign and the SC and CS are reversed. So this is the inverse of cosine, negative 13 over 5. And then cotangent. Theta will be at the negative 5 over 12. So that's using the point to find your trig functions. Okay, and then we also applied the Pythagorean theorem to find out what the hypotenuse in this case is. And we used the form SOHCAHTOA, where sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And then you have the cosecant, secant, and cotangents, which are the inverses of the three main ones. Okay, I hope this has helped.